History is filled with machines that should not exist for their time. Gears too advanced, systems too precise, mechanisms too complex. Even today, engineers and historians argue over how they were built, how they worked, and why their knowledge vanished for centuries. 10. The Ctesibius water organ, 3rd century BC. Back in the 3rd century BC, a Greek guy named Ctesibius got tired of quiet instruments and decided to build something that could literally rattle a stadium. He came up with the hydraulis, but calling it an organ is an understatement. It was a massive, high-pressure machine. The hydraulis used 2 large piston pumps to force air into a water-filled chamber. The water acted as a giant pressure regulator. By using the weight of the water to push back against the air, Ctesibius kept the pressure perfectly steady. Then he linked this air supply to a series of metal sliders and valves. When the player pressed a key, it moved a mechanical linkage that let the pressurized air blast through a specific pipe. Engineers today are still trying to figure out how the Greeks made airtight metal valves and seals without using rubber or plastic. If a single seal leaked, the whole machine would lose pressure and go silent. It shows a level of precision metalworking that we usually think didn't exist until the 1800s. How did they keep a massive air-powered machine running in a world without modern lubricants or gaskets? 9. Zhang Heng's seismoscope, 132 AD. A machine that can tell you exactly where a disaster happened, even if it was 500 miles away across a mountain range. In 132 AD, a Chinese scientist named Zhang Heng built exactly that. He presented a giant bronze vessel to the emperor, covered in 8 dragons and 8 frogs. Inside this bronze shell was a masterpiece of mechanical logic. At the center stood a tall, thin pendulum. This pendulum was linked to a system of 8 different crank arms and levers. When a distant earthquake sent out its invisible ripples through the earth, the pendulum would swing in that specific direction. This motion triggered a tiny internal gear, which caused the dragon facing that direction to open its mouth and drop a bronze ball into a frog's mouth below. The sound of the ball hitting the frog was like an alarm. The crazy part is that this machine was smart. It was designed to ignore local vibrations, like people walking or horses galloping nearby, but it would pick up the specific frequency of a distant mountain shifting. Modern seismologists in 2026 have tried to rebuild this purely mechanical trigger, but getting it to be that sensitive without using electronic sensors is a total nightmare. 8. The Al-Jazari wine servant, 1206 AD. 700 years ago, long before the first computer or the first light bulb, there were robots. One of the most famous was the automated waitress built by a Muslim engineer named Ismail al-Jazari. This was a life-sized mechanical figure that could serve drinks to guests at a party. The brain of this machine was a tipping bucket system. Water would slowly drip into a small container inside the robot. Once that container reached a specific weight, it would suddenly flip over. This quick release of energy triggered a series of pulleys and gears that made the mechanical figure move its arm forward to pour a drink. Once the drink was poured, a counterweight would pull the arm back into its original position. This is what engineers call programmable automation. Al-Jazari could change the timing of the waitress by adjusting how fast the water dripped. He used crankshafts and cams, the same parts you find in a modern car engine, to turn the movement of water into the movement of a human-like arm. Scientists are still studying his designs to understand how he got the motion to be so smooth. It proves that the robot revolution didn't start in a lab in Silicon Valley. It started in a workshop in the 12th century. 7. The Roman polyspastos crane, 1st century AD. When you look at the massive Roman temples with stones weighing 40 or 50 tons, you have to ask, how did they get them up there? They didn't have diesel engines or steel cables. They had the polyspastos. This was a heavy-duty lifting machine that used the most efficient gear ratios of the ancient world. The power for this machine came from a tread wheel, a giant wooden wheel that looked like a hamster wheel for humans. Several men would walk inside the wheel, providing the torque needed to turn the main axle. That axle was connected to a series of 5 interlocking pulleys. In physics, every time you add a pulley, you trade distance for power. By the time the Romans were done with the 5-pulley setup, a small group of men could lift a weight that would normally require hundreds of workers pulling on a rope. The mechanical mystery here is the friction. Moving that much weight creates incredible heat and stress on wooden axles. In 2026, engineers are studying the sacrificial metal plates the Romans might have used to keep the wood from catching fire. They built machines that pushed the absolute limits of what wood and rope could do, and they did it with a level of math that we are still trying to map out today. 6. The castle clock. This wasn't just a clock that told time. It was a fully automated mechanical show. Built by Al-Jazari, the clock of the 3 judges was a massive tower that used water to keep a series of mechanical figures in constant motion. Every hour, the machine would perform a complex sequence. Birds would drop balls into the mouths of dragons, and mechanical judges would strike bells to mark the time. The secret was a constant head water system. To keep the clock accurate, the water had to flow at the exact same speed all day and night. Al-Jazari used a system of floating tanks and valves to make sure the pressure never changed, even as the main tank emptied out. This feedback loop is a key concept in modern engineering. Inside the clock, a series of cams, discs with irregular shapes, rotated and pushed against levers. As the cams turned, they triggered different animations at different times. It was essentially a mechanical movie player. Scientists are still baffled by the longevity of these machines. They were built to run 24/7 in the heat of the desert, using only the flow of water to drive a complex gear train. How did they achieve that kind of reliability without modern stainless steel or precision ball bearings? Which of these machines feels like it came from a time traveler? Drop your theory in the comments and smash that like button. 5. Hero's steam turbine, 1st century AD. Long before the Industrial Revolution changed the world, a mathematician in Roman Egypt named Hero built the Aeolipile. This was the planet's first working steam engine. It consisted of a water-filled cauldron sitting over a fire, connected to a hollow metal sphere by 2 pipes. As the water boiled, steam traveled up the pipes and shot out of 2 curved nozzles on the sphere. The physics here are incredible. This machine used jet propulsion to spin the ball at thousands of rotations per minute. It converted thermal energy into pure mechanical motion. While the Romans mostly used it as a temple wonder, to automatically open heavy doors and impress worshippers, the mechanical potential was massive. In 2026, engineers are using computer models to see how much torque this device could actually produce. If the Romans had linked this spinning sphere to a gear train or a mill, they could have started the age of factories 2,000 years early. Why they left it as a toy remains one of the biggest what-ifs in the history of engineering. 4. The Jacamar Clock Tower. In the late Middle Ages, European cities began competing to see who could build the most insane clock tower. These weren't just for telling time. They were the first public robots. These machines featured jacamars, life-sized metal figures that stood on the outside of the tower and struck the hours on giant bells. The real magic happened behind the clock face. These figures were connected to a massive iron gear train driven by heavy weights. To control their movements, builders used a program drum, which is a large cylinder with metal pegs sticking out of it. As the drum turned, the pegs would catch levers that pulled wires connected to the robot's arms. This is the exact same logic used in a music box, but on a massive, heavy metal scale. The timing required to make a 300-pound metal arm swing and hit a bell at the exact millisecond is a feat of mechanical synchronization that still leaves modern horologists stunned. 3. Colossus. Computer. The Colossus computer was a mechanical milestone that proved the impossible could be done with enough vacuum tubes and sheer engineering grit. During World War II, the British needed to crack the Tunny code, a cipher so complex it made the famous Enigma look like a toy. While everyone else thought thousands of glass tubes would just explode under the pressure, a post office engineer named Tommy Flowers bet they could handle the heat. This machine wasn't just a calculator, it was an electronic predator. Imagine miles of paper tape screaming through a reader at 30 miles per hour, while 2,500 vacuum tubes blinked and hummed in a frantic race against the German high command. It didn't just guess the code, it used pure electronic logic to find the invisible patterns hidden in the radio waves. Colossus turned the tide of the war by becoming the world's first large-scale digital programmable computer too. The Al-Jazari elephant clock. This is widely considered the most complex machine of the medieval world. It was a giant, water-powered clock shaped like an elephant, but inside it was a masterpiece of chain reaction mechanics. It used a sinking bowl with a tiny hole in the bottom to track time. Every half hour, the bowl would submerge, triggering a release of bronze balls. These balls would roll through the machine, causing a bird to chirp, a dragon to rotate, and a mechanical rider to strike a drum. Once the sequence ended, a system of pulleys would automatically reset the bowl for the next cycle. This is what we call a closed-loop system. It required no human intervention to keep running. The way Al-Jazari calculated the flow of water and the weight of the balls to keep the clock accurate to the minute is a level of precision engineering that wouldn't be seen again for centuries. 1. The Antikythera mechanism. The top spot goes to the most famous artifact from the future ever found. In 1901, divers found a green, corroded lump in a shipwreck. After decades of X-ray study, we now know it is an analog computer with over 30 hand-cut bronze gears. It is roughly the size of a shoebox, and by turning one single crank, the entire machine comes to life. The gears are calculated to track the exact movements of the Sun, the Moon, and 5 planets. It even has a special gear with an epicyclic motion to account for the Moon's irregular orbit. This requires math that involves complex fractions and gear ratios that weren't reinvented until the 1600s. How did someone in 150 BC design a portable, handheld device that could predict eclipses decades in advance? It is the ultimate mechanical mystery, indicating that a high-tech era existed in the ancient world and was somehow completely lost to time. We've explored 10 machines that refuse to fit neatly into our understanding of history and science, and that's what makes them powerful. They remind us that not everything has been figured out. If this kind of mystery pulls you in, subscribe to The Missing Clue and hit like, because the next unanswered question might be even stranger than this one.